publishing space-time is in jeopardy, that are saying that, which is, you're saying it's in jeopardy, that means it's already out, right? Which if you're saying it's in jeopardy, that means it's already out. It's not a scientific, because if you haven't proved something scientifically, it's not a hypothesis theory. It's at the most they never observed space-time because those are two, but they never observed conceptual time because those are two, abstractions, conceptual touch or hold. So it's theoretical at the end of the day, which means by definition it can't be theoretical at the end of the day. But whatever, we've accepted it into the science. But whatever, we've accepted it into the mainstream. Into the science, I like to watch into the scientific mainstream. And so I like to watch another. So that's basically what they're writing about right now. So that's basically the debunking. What they're writing about right now, like I said, the dark debunking of. So now not even just like I said, dark matter. So gravity is supposed to be the bending and warping of space-time. So gravity that only works right if they can space-time. But that only works right if they can 83% of all fake dark matter in matter. 83% of all 97% of all energy in the universe is 97% of all energy in the universe. So basically, their equations don't work. So basically, their equations don't work percentile. So that's already saying it doesn't work. And now, right now they're saying like we can't even prove the existence of space. Right now they're saying like we can't even prove the existence of, like I said, are by definition conceptual, which like I said are abstractions. By definition conceptual abstractions. But now this is just the proof. Like they already don't exist. But now this is just sides now agree. There's no right. The side that both sides on scientific consensus, right? The side that disagrees is on scientific come together and agree now. Like it looks like there is. We all have to come together and agree now. What we think gravity is really is just an electrostatic, and what we think gravity is really is just an electrostatic relationship that everything has with one another. All right.
What do you mean by space-time is doomed?
Great.
What do you mean by space-time is doomed?
Not my quote. This is by the way, Nima Arkani Hamed. This is from the Institute for Advanced Study at Princeton, Ed Witten at the Institute for Advanced Study at Princeton, Dan Witten. Nobel Prize winner. So this is not just something the cognitive scientists are saying. So this is not just something the cognitive scientists. This is what physicists are saying.
Yeah, the physicists are space-time.
Yeah, they're saying that, and I can say exactly why. Yeah, they're saying that, and I can say exactly is why, because your question was doomed. But what they're saying is that, what we're talking about, because your question was both space and time. Space-time. Their union into space-time is both space and time. That's their union into space-time as in Einstein's theory. They're basically saying that, and even they're basically saying that Nima Arkani Hamed, even quantum theory, this is Nima Arkani Hamed will not be fundamental either. So Hilbert space will not be fundamental space, which is really critical to the notion of Hilbert field theory, which is really critical to.
Right. So as they do experiments, right. So as they do experiments, obsolete. It has no bearing on the reality. It has no bearing in the part on the reality that they're seeing in the part of with new theories of physics that are basically coming up with new theories of physics that are rendering the rest of these theories superseding all of these and rendering the rest of these theories useless. If I'm not mistaken, so as you get rid of Hilbert theory, if I'm not mistaken, yeah, if I'm not mistaken, Hilbert theory is a key fundamental of quantum theory altogether. So once Hilbert theory goes, then there is no theory altogether. So once Hilbert theory goes, then there is no quantum theory anymore. So it's like now we're back at nothing. Nobody knows anything anymore.
That's not going to figure in the fundamental. That's not going to figure in. So what they're looking for is some new laws of physics. So what they're looking for is some beyond space, new mathematical structures. Beyond Einstein's four-dimensional space-time, beyond Einstein's four-dimensional space-time, geometric algebra signature, supersymmetric comma four kind of geometric algebra signature represent comma four kind of. They're finding there are different ways to represent. And by the way, they're finding they found something called the amplituhedron. They're succeeding, and they're finding they found something called the amplituhedron, the cosmological polytope. These are so there are these like the cosmological polytope. These are polytopes. So there are these like in multi-dimensions polytopes, generalizations of simplicity in multi-dimensions that are generalizations of simplicity for example the scattering amplitudes of processes in the Large Hadron Collider. For example, the scattering amplitudes of processes. So they're finding that if they let go of space colliders. So they're finding that if they let go, finding new ways of computing these scattering amplitudes. They're finding new ways of computing these scattering terms into one term. Turn literally billions of terms into one term.
Ever been said. All right. So that's one of the most important things. So when I say something like everything all matter, when I say something like everything all matter, is just condensed whatever word you want to use, or condensed electricity, whatever word you want to use. It's quarks, and they say no, it's not neutrons, and all these different things. And neutrons, and so these are all theories, right? Until they do. So these are all theories, right? Until they do. They're trying to fit what they're seeing into the mathematical, into what they're seeing into the mathematical, right? That has all these different variables in it. Model, and they're saying like, look, all these different variables to make it. And they're saying like, look, what we do to make all these variables, and we find a way to condense them into the same all these variables, and we find a way to condense them into the same variable. I try to make everything in different ways possible, so the average. I try to make everything as simple as possible, so the average person can understand. And like all these different things that they think exist, and it's all these different things that they think exist, and based upon what they see see in the reality, if they assume that all these things are basically just one thing, if they assume that all these things are basically just one thing, these are one thing. If they assume acting in different ways, these are one. It makes their math acting in different ways closer. It makes their math more simple. My theory that everything is closer in line with my theory that everything is dielectric. And that's a deeper version of it, right? I mean, but and that's on the surface, right? It's complete. They're saying on the surface, right? It's complete. They're saying space and time as a factor, remove right? Space and time more sense what we're seeing, right? In the quote unquote coding, sense what we're seeing, of what is happening when these particles smash together. Right, of what is happening when these particles fake space-time to it, then we try to add literally doesn't make sense. Space-time to it, then it literally doesn't make sense, and we have no idea what's going on.
When you do it in space and time, because it's the wrong framework. When you do it in space and time, just because it's the wrong framework. That's not from the evolutionary point of view. It's just user interface.
Right. So just to make it as simple, he's saying like right. So just to make it as simple, he's saying like particular user interface is just an evolutionary particular user interface, and it's just an evolutionary, evolutionarily or adaptatively, to view the world in the realm of space-time, the way we view the world in the realm of user interface, the way we do it now. But that's the user interface. Like we know the first computers didn't even have interfaces. We know the first computers didn't even have do some work and then print out to see what it is. You had to do some work, so this interface out to see what here on my computer. That's not what's actually going on here on my computer. That's not what's actually going on under the hood. So this is just the interface that relates to the environment that I'm around and relate to the environment that I'm around, the information intake from what's useful, control the information intake from what's useful and not you saying that when we look at the collider, we have to basically remove that when we look at the collider, understand that that's basically just a construct, right? And understand that that's basically just together. It's just a construct of our own mind. Together, it's just we remove that, then what we're seeing in the collider. So once we actually remove that, then what we're seeing in the collider actually makes sense. If that makes sense.
It's not a deep insight into the nature of reality. So it's missing deep symmetry of reality. So it's missing deep symmetry. It's not a deep insight into the nature of reality. So it's missing deep symmetry is something called dual conformal symmetry, which turns out symmetry is something called dual conformal chemistry in space, which turns out to be true. And is making the computations way too complicated. And is making the compute all the computations way too complicated. You're trying to compute all the loops. See, the Feynman approach to the scattering amplitudes is trying to enforce the Feynman approach to the scattering amplitudes is trying to enforce two critical properties of space. So by when you enforce those, you get all these loops. So by when you enforce those, you get all these loops.
Oh man, this is such a deep subject. Basically, what he's saying, there's so much. To think about it, locality and unitary. To think about it, locality and unitary. These are the two concepts that are holding us back. These are the two concepts that are holding us back when it comes to space. Are atoms individual, or are they one atoms individual, or are they one connected? Once we remove the idea of locality, once we remove the idea of locality, once we stop doing that, he's saying once we stop doing that, he's saying then it opens up the whole spectrum and things start to make sense based on locality. Once we try to pinpoint things based on locality, it turns one variable into a billion variables. It turns one variable into a billion variables, and even the top supercomputers on the planet cannot compute that.
And multiple, different levels of loops, and for each of those you have to add new terms to your different levels of loops. And for each of those you have to add new terms to your computation. But when you don't have the notion of unitarity. You don't have the notion of locality. You don't have the notion of unitarity. You have something deeper. You don't have the notion of capturing some symmetries. There's something deeper data. And it's capturing some symmetries. Then when you look at the geometry of the facets, but then when you look at the geometry of the facets, certain of them will code for. Then unitarity, certain of them will code for.
I'm gonna stop it right there.
And locality.
I'm gonna stop it right there. But that last thing he's saying, there's just so much in this video. Right, but that last thing, the computer coding example, like I said, right? It's like when you're coding example, right? The computer code doesn't look like when you're coding with the website. Right, the computer code doesn't look at the website like with the website. We're examining the website. We look at the website, trying to figure out what's going on just in the parameters. Trying to figure out what's going on of the website in the parameters. He's saying in the collider of the website. This is not literally. He's saying in the collider. This is not. I'm trying to dumb this down to the average. I'm trying to dumb this did. I'm trying to basically what he's saying is when we look at the collider, so basically what he's saying is interact with each other. When we look at the collider, we're looking for patterns, right, that repeat. We're looking for patterns, right, like we're looking for the ones that allow us to, right, like we're looking for the ones and the zeros, right, right, like we're the ones and the zeros, all the way down to what is the pattern behind it, breaking it all the way down to what is the pattern behind it that is giving way to the interface that we're seeing. That when we do that, that's basically what he's saying is that when we do that, right, the actual structure that they're calling it is the actual structure that they're calling it is that. But again, that's just another made-up name, right? But again, that's just another made-up name, right? For basically like a movement. They can't say it's a shape anymore. So that's why we don't, when they say stuff like light. So that's why we don't, when they say stuff like light, like people and modern science, they say stuff like that. Like light is a particle. Modern science, they say stuff like that. Like light is a particle. Light can't be a wave. Nothing can be a wave unless you're describing what it's doing. Unless yes, you're describing what it's doing to something else. He's saying that,
which is exactly basically what he's saying.
When we look at things saying that like locality, when we look at things like locality can actually be represented. Locality can actually be represented of the amplitahedron.
Basically, like the
so instead of looking at things as
the thing.
So instead
of
looking
here,
at things
right?
as
We're looking at it
the
as
thing
when
is
it does
here,
this
right?
movement,
We're looking at
when
it
it does
as
this movement,
when it does this movement, it's there.
Right?
When it does this movement,
light,
it
for
appears
example,
to be
right?
here.
People like to say light is a
Like
particle.
light, for example,
light isn't a
people like to
particle.
say light
Light
is a particle.
something that
light is something that
quote unquote particles.
Light is something that quote unquote particles.
So when they
do.
say light is a wave,
right?
So
when they say light is a wave,
what is waving?
right? So it is
Right?
a wave, but what
waving
is waving
that gives light,
right?
What
Light's
is
not a
waving?
particle, it's
that
what
gives
something
light,
looks like
right?
when
Light's
it
not a
does a
particle,
certain
it's
motion.
what
something looks like when it
All
does
right?
a certain motion.
I'm trying to say it in the simplest
All right?
way.
So
in the simplest way
possible. But essentially, that's what they're discovering. But essentially, that's what they're discovering.
Light years
right?
past
But like I
whether
said,
or not
this is
gravity
like
exists.
light years
not
past
only does
whether or not gravity not exist. The particles not only doesn't atoms not exist. The particles there are different modalities, right? Or different movements, different modalities, right?
They're calling amplitahedrons
of, but an
amplitahedron
amplitahedron
is just a shape.
amplitahedrons.
But an amplitahedron is just a shape.
Something can't be.
I hope this makes sense.
Something
Like,
can't. If you're saying that something is a square, right?
Okay, but
if you're
a
saying that
square
something is a square,
actually
right?
a thing.
Okay, but
It's
a
just
square
a shape that a thing
isn't
makes.
actually a
So it
thing.
has
It's
to be a
just
shape of
that a
something.
thing makes.
They don't want to
So it
admit
has
that
to
it's
be a
just
shape of
dielectricity because
They don't want to
admit
admit that it's
just
dielectricity
comes with free energy.
Like I said in my debate,
That's what this leads
that
to.
comes
Once
with
you
free
admit that
energy.
everything is energy,
That's what
everything
this
is
leads to.
electricity.
Once you
now
admit
we don't
that
have to
everything
pay
is
for it
energy,
anymore.
everything is
We can
electricity.
access it for
Now we
free
don't have to
from
pay for it anymore.
the
We can
ether,
access
the
it
air,
for
the
free
medium,
from
whatever it is that you want to call
the
it. You know what I
ether,
mean?
the air,
So,
the medium.
I
I have so many more. So many more examples. I have so many more
talking about how
so many more examples
what we
of
see,
professors
what we
talking
see
about
in
how
the large heat-on,
what we see in the colliders,
in the
right?
large heat-on.
Not only do they
in the colliders
support that there's
right?
no gravity,
Not only do
that's
they
been done 100 years
support
already.
that there's no
But
gravity,
they support
that's been
the
done 100
idea
years
that
already.
everything
But
is
they support
one
the idea that everything
all
is
life-giving substance.
one right.
All
like
life
in the
giving
beginning, in the first part of the
right?
first video that I showed,
like in the beginning, in the
the
first
part
part
that
of the
I skipped,
first
he
video
said
that I
that
showed,
in the same way
the
that
part
he's
that I
not
skipped, he
confident
said that
about
in the same
dark
way
matter,
that he's
in
not
the same way he's
confident
confident
about
about
dark
matter
matter
not being
in
there.
the same way he's
That's how
confident
confident
about
he
dark
is in
matter
the
not
existence
being there.
of
That's how confident
Higgs
he is in
boson,
the existence of
right? Or
the
God,
Higgs
the God
boson
particle,
right? Which to me is
or
just
the
another way of
the
saying
God
ether.
particle.
They're like, there's a
which to me
particle
is just
there
another way of saying
that
ether.
holds
They're like, there's a
electricity,
particle
and when we
there
need it, it
that
brings
holds
electricity into the universe.
and when we
That's the
need
same
it,
thing
it brings
that Tesla
electricity
described
into the
when
universe.
he was talking
That's
about
the same thing that
you know.
Tesla described.
So
when he was talking
that's my
about
quick
ether,
little spiel
you know.
on.
So that's my quick little.
I mean,
spiel
why
on-
gravity is a
on
turkey.
on.
I mean,
I mean, why gravity
I
is
can't
a
believe
turkey.
anybody
I mean,
brings that up.
I
in the-
can't
in the
believe
base
anybody
anymore because,
actually
like I said,
brings that
they
up
stopped
in the base
making
anymore
it
'cause,
about
like I said,
mass.
they
They stopped
stopped
making it
So
about mass
since
in
1930 all the way
1930.
past
So
1950
since
to now,
1930
it's been
all the way
bending and
past
warping of space-time,
1950 to now,
right?
it's been
Based
the bending and
upon
warping of
the
space
existence of dark
right?
matter.
Dark
Based
matter has
upon
already
the
been
existence of
debunked.
dark matter.
And like I said,
dark matter
already
was
been
never
debunked. And like I said,
and then
dark matter was
space-time
never
in general has
anything
been
real.
debunked.
And then
So there is no
space-time
gravity,
in
there is
general
no
has been
space-time,
debunked.
there is no
So there is
bending
no
and the warping
gravity,
of
there is
space-time.
no space-time,
You know
there
what
is
I
no
mean?
bending and the warping.
Intellectually, if we really want to find out what's going on, we gotta let
intellectually, if we really want to find out what's going on, and then move on.
We gotta let that die.
Parsing
And
through
then
all the
move
information
on
that's coming out of the
to
colliders,
parsing through all the
information that's coming out of the colliders, because they're publishing papers every day. And I'm reading them because they're publishing papers every day. And I'm reading them even before I started watching the flat Earth debate. Before I started, I already was on the side of. I already was on the side of that. Quote unquote true Earth. I already understood that there's something. Think the Earth is not what it is. That there's something a lot more fluid going on. There's something a lot more fluid going on. Quote unquote solid universe. You know what I mean? It's not nowhere near solid as we think it is. Solid universe. And there's a direct connection between what we perceive to be solid and our direct what we perceive to be solid and our direct experiment that have been done to prove this. Like I said, there's experiment after experiment that have been done to prove this. But I have another one that deals with gravity. I have another one that and specifically what's going on gravity and specifically what's going on, specifically what the Earth is and what the force that we think, specifically what the Earth is and what the force that we think.
I'll watch the last video, then I'll ask.
But you're more than welcome to jump in. You're more than welcome to jump in.
I'll watch the last video, then I'll ask some questions. I'll watch the last video, then I'll ask some questions.
Okay. It's not even the right video. This is not the right one, but this is like this is an example. This is not the right one, but this is like this is an example though. This is of gravity. What we're talking about. This is what gravity is. So right here. Different magnetic fields. So like I said, everything different energy, frequency, electricity. Everything is magnetism, frequency, electricity. It's like different modalities. All same thing. It's like different modalities of water. Ice. You know what I mean? All these things are water, but different modalities. Ice. So you know what I mean? Electricity, magnetism. It's all the same thing. So when you have electricity, magnetism, it's all the same thing. Fields. So when you have two coherent fields, I don't want to get too you know what I mean? So coherent and non-coherent fields have a reaction on each other, right? Non-coherent fields have a reaction on each other, right? They either think about an incoherent field. So is that the thing about bigger the incoherent field is that the bigger the incoherent field. So the Earth is one large coherent field. So Earth we have a very large coherent field. Attraction. We have a very is an attraction there, which gives us our downward bias. Attraction there, right? Which gives us our downward bias, right? An electric charge pushing down on the Earth. That's measurable. An electric charge 100 volts per meter as you go up, right? 100 volts per meter as you go up. Measurable. And measurable. You can run a C word generator. You can run a C word generator, harnessing the electromagnetism, harnessing the atmosphere, and converting it into energy. So this is how you can use magnetism into energy. Magnetism. So this is how you can use magnetism. Like essentially, what we're watching is we're watching energy. Like essentially, what we're watching is we're watching energy being pulled from the ether. You know what I mean? Like I say, without nobody really understands what's going on. Like nobody really understands what's going on. Like there was one person that felt like he understood what was going on. There was one person that Nikola Tesla understood by the way he invented everything. They was Nikola Tesla. So by the way he invented everything. We haven't had any discoveries that we haven't said those two had any discoveries that go against it. Like I said, those two scientists that I showed talking about what they were discovering in the colliders, talking about that they were discovering in the colliders, saying like, oh wow, that's them all basically saying like, oh wow, that basically all the stuff that we tried to debunk Tesla, it was all wrong. We're having to go back to what Tesla knew. We're having to go back to what Tesla knew. Like I said, this is a wrong video. There's another video that this is a really shows. There's another video that really shows exactly how different Earth and how we on the Earth and how we react to the Earth. Anyway, how we react to it's really neither here nor there. Like I said, I personally, it's really neither here nor there. Like I said, I personally feel like gravity is a cooked turkey. But I always like to spin it into something that is useful and valuable. Spin it into something that is useful and valuable for the. My favorite thing to say is because science is irrelevant if it doesn't improve the life of the average. Science is irrelevant. You be the greatest scientist ever, have the greatest inventions ever. You be the greatest scientist ever in the cave, greatest inventions ever. Use it. But if you do it all in the cave and nobody gets to use it, then it means nothing. It really didn't. So that's my spiel, man.
That you read.
So that's my spiel, man.
Okay.
I'm ready for your question.
In the debate that you had, I heard you say that you read the paper. I remember you mentioned that you read the paper. I remember you mentioned that you had with Leo in the debate that you had with Leo filers on the screen. You didn't. How many of them I wasn't clear on? Did you read all 7 of those papers? I wasn't clear on. Did you read all 7 of those papers? You didn't. How many of them did you read?
I mean, well, I read.
How many of them did you read?
I mean, well, I read the actual page that I could access without paying for it. I read everything that I could access without paying for it. I read everything that I could read without paying for it. But these are I don't want to say old papers, but here I'll pull them back up for you because I have them right here.
Okay.
Let's see 1 second. Right, so these papers are basically reporting. These papers are basically like this is all stuff reporting data. And like I said, like literally this is all stuff that I and the hill that I was dying on before I ever heard. And the hill that I was dying on before I had ever heard. I didn't read these papers, no, but these papers are. I didn't read these papers, no, but these papers are was trying that I personally all of my friends was trying to. About what was really going on with the world before I even accepted. About what was really going on with the world before I even accepted as an interesting subject. Flat Earth. So they're talking about interesting subject. So they're talking about old experiments that have been done at infinitum. Like I said, these are old experiments that have been done at infinitum. Right. Quote unquote gravity, right? Quote unquote gravity. Quote unquote gravity, right? Like you can do this through experimentation, Van graph generators. You can do this during my debate. I showed Van graph generators levitates. During my debate, I showed us changing sound levitates, the gravitational nature of the object, the gravitational nature of the object, and thus changing the effect that we see as thus changing the effect. So that also happens during thunderstorms. So that also happens, and not only just thunderstorms, but it affects and not only just thunderstorms, but it affects at the same electromagnetic frequencies. So when there's a thunderstorm at the same time, right? So when there's a thunderstorm, obviously the magnetic fields are being disrupted. Our magnetic fields are being disrupted. You can actually measure that, and then you can measure you can actually measure that, which and then you can measure.
And that's what this paper here is saying.
Which things fall during a thunderstorm and outside of a thunderstorm. There's clearly during a thunderstorm and outside of a thunderstorm. That shows that there is an electric
That's what this paper here is saying.
That shows that there is an
That's what this paper here is saying.
This one right here. Oh well, this and all these paper are this one right here. All based upon these paper are principle. All that's like based upon it's such a principle because that's like I said, it's such a principle that's been like beat into the ground so much. It's a principle that's been like beat into the ground so much. That's why I really didn't even need to read. It's just the backup that I brought just in case. But it's just the backup most of the people I brought just in case. You know, they worship. I know most of the people who watch. If it doesn't say it in the paper, then I don't believe it. If it doesn't say it in the paper, then I don't believe it. Really about paper. All right, well, no, science actually isn't really about paper. Yes, you show the observations on paper, and yes, you show the observations on paper. Yes, you show the paper themselves. Experiments on paper is not the evidence. But the paper themselves, you still, if you still want to know for sure, I mean, you would still, if you still want to know for sure, you would still have to. I just like
what you're
they're all on pretty
saying
much the same.
Gravity,
the
gravity changes in a
nature
thunderstorm.
of gravity, right?
And what you're saying is that gravity changes in a thunderstorm. Okay.
Well, what we perceive to be gravity, which is basically the rate at which things fall. Right. The rate at which things fall changes during thunderstorms. Yes.
One moment here.
At infinitum. It's like, yeah.
Right. So this paper is actually pretty short.
Go ahead. No problem.
How am I able to share? So this paper is actually pretty short. Can I share the screen on this thing? Or can I share something on this thing? How am I able to share? I'll just hit present.
Go ahead.
Can I share the screen on this thing? Or can I share
something?
Oh,
yeah. I believe so.
Here. Oh, I see. I'll just hit present there. Okay, hold up. Let me try to get this worked out so I can share this here.
Go ahead.
It's actually downloaded. Let's open it up. Open up the actual PDF. And it might be better if I. It's actually downloaded. Let's open it up. Open up the actual PDF. All right, there we go. So present. Right, so present. Your screen. They're gonna let me pick what screen or there we go. But it's working. Okay. They're gonna let me know if you're able to see the paper now. There we go. It's working.
It is?
Okay. So let me know if you're able to see the paper now. Let me zoom this thing in.
Yes.
During the past 3 decades, a number of investigators reported. Let me zoom this thing in. Services, and in particular, sporadic. During the past 3 decades, a number of investigators reported evidence. Here we read it. So it's saying ionospheric disturbances. And let me know if you catch the part where it says gravity change. Right. So it's saying ionospheric disturbances. This is the first one you pulled up. And let me know if you catch the part where it says gravity changes. Thunderstorm formation. And this is the first one you pulled up from nature, the mechanism for the generation. I'm trying to see if this. Did you say this thunderstorm formation?
You want to see if it matches what you're saying
or supporting. I'm trying to see if this. Because you said, let me know if you see it before I do. I'm trying to see if it matches what you're saying is saying or supporting.
Okay.
Right. And let me know if you see it before I do.
Well. Okay. So I'm go to the top real quick, right? So just for example, right, the driving force for the updraft would seem to be an instability of the lower atmosphere, right? So even something as simple as that is them admitting that there are other variables besides the weight, right, that affects the rate at which things fall. You know what I mean? And not even just other variables, they're saying the driving force seems to be a disturbance, right? So there's a disturbance in the lower atmosphere that is affecting it, right? So it doesn't necessarily.
So what exactly does updraft mean? What exactly does updraft mean? What exactly is the updraft?
The driving force for the updraft. I mean,
what exactly does updraft mean?
I mean, just in context, I'm assuming they're talking about the variable recordings of the data.
Updraft means the variables of the recording of the data. What's the rest of the context?
I'm saying in context. I'm just like, reading it in context.
But what's the rest of the context? Well, that's what I was starting to do, but you stopped me at a sentence.
You want to read the whole paper right now? I mean, we can, you feel me? But it's.
But that's what I was starting to do, but you stopped me at a sentence and started. I mean, it's only like
it shouldn't
be long. to scroll through. I mean, I don't
if you want to read the whole paper, go ahead. You feel me? But
I mean, it's only like 2 pages, so it's not. It shouldn't be long. Actually, it's not even 2 pages. It's like a page and a half. I don't necessarily think you need to read the whole thing in detail, but the whole thing, the article itself is a page and a half. Actually, it's not even 2 pages. It's like a page and a half. Scroll through this one. The bottom of it is actually a different article. What you see. So the article itself is a page and a half. Updraw explanation. So we can scroll through this one here and see if grouping of data doesn't support the idea that gravity is changing. To my understanding, updraw explanation. We'll go through it being some kind of during the past 3 grouping of data doesn't support the idea that gravity is changing. To my understanding, so indicate that thunderstorm activity may be during the past 3 decades. A number of ionospheric experimental evidence, and in particular, which seem to indicate that thunderstorm activity may be related to ionospheric ionospheric disturbances, and in particular, the sporadic E. So what is the E? What does the E here stand for when it says sporadic E? During the past 3 decades, a number of investigators have reported experimental evidence. It says to indicate that during the past 3 decades, a number of investigators have reported experimental evidence, which was seen to indicate that thunderstorm activity may be related to ionospheric disturbances, and in particular, to sporadic E. What does this E stand for here? Do you think E is the beginning of someone's name?
I'm assuming that it's the beginning of this guy's name. I don't.
Do you think E is the beginning of someone's name?
Yeah, I'm assuming it's too sporadic. E. Roberts et al. Have provided more recent evidence in their data of path losses of 21.6 MC per second radio waves transmitted from Panama and received at Stockbridge. So this is them. This is actually the.
Hold on, we're just talking about just the E right now. So you're saying the E is the first part of this guy's name.
The gravitational
waves.
So you're
saying in particular. Hold on, we're just talking about just the E right now. So you're saying the E is the first part of this guy's name. That's what you're saying. So you're saying they're saying in particular, who sporadic E. Roberts et al. Have provided more recent evidence. That's provided more recent evidence in their data of PAT losses.
At first glance, right here, that's what I'm going.
And what is this units right here? That's provided more recent evidence in their data of PAT losses of 21.6. And what is this units right here? Perhaps we could just stick together and go through it.
I'm trying to read and listen to you at the same time, bro. Ask me again, bro. My bad. I'm trying. I can't do it.
It says. So, according to your reading, data of PAT losses of 21.6 provided more recent evidence right here. So I'm asking you, what is this data of PAT losses right here of 21.6 MC/S? So I'm asking is what is that MC/S right here?
That's megacycles per second.
What does that stand for mean? What would that be? What would that relate to?
Yeah, because megahertz is MH. So I think it's megacycles.
What would that be, or what would that relate to?
Okay. All right. So if like I said, if we're saying that light is away, because this is them sending basically light frequencies from one path to another, right? I don't think this one is specifically about the gravity of objects. I think it's about how basically lightning is affecting the cycles per second of the light beams that they're sending from one point to another. So they're showing how
this is not saying gravity is changing anymore.
They're saying that the gravitational effect that is present on all light beams, right? Because there's a gravitational downward bias on all things, and you can test it through laser interferometry. Right. So if you have a laser,
the 21.
If you have a laser,
we just didn't get there yet. Like I said, there's only a page and a half. Okay. We just didn't get there yet. Let's see what we got.
Well, I'm basing that off what I've read in this first section, because they're talking about sending laser. They're talking about sending beams from one place to another, essentially, right? And the cycles per second, right? The frequency of the laser is being affected during a thunderstorm, right? And that is akin to gravitational pull, because if I shoot that laser, right, that's how they basically know that there's a quote unquote effect of gravity. You can have like I said, if I'm shooting a laser, right, you will see a very, very tiny downward bias that's affecting the frequency, the cycles per minute or whatever it is that you want to place as a meter of measurement on it. And they're saying that it's affected during thunderstorms.
Like
right?
what words? So I need you to point out where exactly did you get that understanding from what you read so far. Like, what words is it that let you know that
Let's see that.
all
What
you
I'm
said
saying
just now?
from that,
is
Right.
what gives
Radio
gravity
waves
pulling
transmitted from Panama
down
and
and
received at Stockbridge, New York. They reported a new
let's see
time
that. What I'm
disturbance.
saying from
I'll
that,
tell you
what
what I
do you
read.
get gravity pulling
This
down and
well, like I said,
which one of
when you
these
asked me
have
if I
you
had
read
read all
that you
these
pulled
articles, I'm
up?
like, no, I didn't read all the articles because this is something that I've been knowing for years, right?
Okay.
That everything
So
is
which one of
let's
these
finish
have
let's
you read
finish
that you
this one.
pulled up? So we know that it's
I didn't
transmitting
read
radio
any of the
wave,
articles. Yeah,
right?
I didn't. Yeah,
So let's finish
That's
this
right.
one in.
Yeah.
So
And
we
I'm
know
telling you,
that it's
this is what
transmitting
I was
radio
reading right
wave,
here. Radio waves
right?
transmitted from Panama received at Stockbridge. They reported a new time disturbance, right? The new time disturbance represented a marked decrease in adoption below normal levels. Onset trend occurred between, you know what I mean? And honestly, bro, I would encourage you, if you really want to know the truth, right?
What
I
I'm
would
doing
encourage you
is
to
you
take this
said this
and
paper
read it in
says
your
a
own
certain
time. You know what I
thing,
mean?
and
Like,
you express having an
like literally,
understanding of
like
gravity and an understanding of what
what
this paper
I'm
says
doing
from
is
reading the
you
page.
said
This paper says a certain thing, and you
you don't
express
remember what you
having an
said. I mean,
understanding of
we were
gravity
talking.
and an understanding of
Then
what
let's
what
read
did
the
I say
paper and
specifically?
see
What did I
if
say
it says
specifically?
that. All right. You don't remember what
so
you said? I
I
mean,
remember what I
onset
said
temperature
specifically. I
occur
want to know if
between
you know what I
then
said.
let's read the paper and see if it says that. All right.
we find this
So
evidence particularly
onset
suggestive as the
temperature occur
past
between
over a portion
11:15
of
and
Florida,
12:15 Eastern
especially
Time. The
noted
disturbance
for
duration was
intensive
about 1
thunderstorm
hour.
activity.
We find this
One of
evidence
our
particularly
colleagues, W.J.
suggestive as the
Brentley, has checked
past
on
over a
thunderstorm
portion of
activity
Florida,
August
especially
19,
noted for
2022,
intensive
decided
thunderstorm
by
activity.
Robert A. Tall, who
One
was
of
in
our
time
colleagues,
observer,
W.J.
found
Brentley,
that the
has checked
thunderstorm
on
did
thunderstorm
exist in the region
activity
near the propagating
August
pad.
19, one of the two
Furthermore, the
instances
fact that the
decided
function
by
occurred in the
Robert A.
summer
Tall,
months
who
from
was
the
in the
early
time
months would
service
seemingly
reserve, and found that the
signal
thunderstorm did
corroborating
exist in
important
the
times
region
of the
near the
meantime
propagating
disturbances.
pad.
This
Furthermore, the
evidence is
fact that
highly
the function occurred
circumstantial.
in the summer
Also,
months
to
and the
the
early
information,
months
it
would
does
seem
seem to reinforce the belief that
to
Florida reaches
corroborate
Florida
for
to
the times and the
consequences
meantime
of thunderstorms
disturbance.
can exert an influence
This
on the
evidence is highly
ionosphere,
circumstantial.
and that additional
Also, previous
experiment should be
information, it
carried
does
out
seem to
that will
reinforce the
provide
belief
more
that Florida
conclusive
reaches
evidence.
Florida to possible thunderstorms can exert an
I don't see
influence
it yet.
on the
Did you see the
ionosphere,
part yet? Or
and
should
that
we just
additional
keep going?
experiment should be carried out that will provide more conclusive
We're talking
evidence.
so far about effects on the
I don't
ionosphere of
see it yet. Did you
thunderstorms.
see the part yet, or should we
In
just
this
keep
article, we
going?
shall suggest a mechanism by which energy can be
I'm
We're
not
transferred
gonna
talking
lie,
from
so
the
far
thunderstorm
about
during the
effects on
stratosphere
the
to the
ionosphere of
ionosphere, by
thunderstorm.
which an ionosphere
In this
disturbance can
article,
be
we shall
created.
suggest a
The
mechanism
mechanism
by which
involves the
energy can be
generation of
propagated
acoustic
from a
gravity
thunderstorm
waves by
during the
air
starter
movements in
stages
a
to the
thunderstorm,
ionosphere,
and the
by which an
propagation of these
ionospheric
waves to
disturbance can be
ionospheric
created.
levels.
The
So some
mechanism involves the
mechanism will
generation of
generate
acoustic gravity
acoustic
waves by
waves
air
by
movements in
air
a
movement in the
thunderstorm and the
thunderstorm.
propagation of these waves to
They believe that
ionospheric
acoustic
levels.
gravity waves
We're talking
propagated
about a
upward from the
mechanism that will
troposphere and will be
generate
responsible
acoustic
for a number of
waves
types of
by air
ionospheric
movement in the
disturbances has
thunderstorm.
become
Okay?
increasingly widespread
They
in
believe that
recent
acoustic
years.
gravity wave
Science has showed
propagating
that
upward from
many
the
of the most
troposphere may be
observational
responsible
data
for a number of
pertaining
types of
to
ionospheric
irregularities and
disturbances
motions
has become
in
increasingly
the
widespread in
atmosphere may be
recent years.
interpreted on the
Science
basis.
has showed
Okay,
that
so
many
it's
of the
saying
most
Hines has
observational data
shown that
pertaining to
many or
irregularities
most
and
of the
motions
observational data
in the
pertaining to
atmosphere may be interpreted on
irregularities
the basis
and
of. Okay,
irregular
so it's
motions
saying
in the
Hines has
atmosphere
shown
can
that
be
many or
interpreted
most
on
of
the
the
basis of
observational data
atmospheric gravity
pertaining to
waves. That is
irregularities
acoustic
and
gravity
irregular
waves. So it's
motions in the
telling you
upper
that is
atmosphere can be
atmospheric.
interpreted
The
on the basis
atmosphere
of
is not
atmospheric gravity
is
waves.
not
That
moving
is
necessarily
acoustic gravity
how we would
waves. So it's
anticipate,
telling you that
except for
there's
gravity waves being created
atmospheric. The
in the
atmosphere is
atmosphere. And that's why so they
not moving necessarily how we would anticipate, except for gravity waves being created in the atmosphere.
Quote
And that's
unquote
why
gravity wave. They're just using the word gravity waves. It's the same thing, like I said, it's saying electromagnetic frequencies, mechanical waves. That's what they say. Radio waves, whatever word they want to put to it, they're calling it gravity waves. But like I said, it's electromagnetic frequencies
the word
that are
you're getting
affecting the
from
rate
this
at
that
which
they're
things
saying is
move and are
electromagnetic
attracted to
waves.
each other electrostatically.
Like, where are they saying that?
So I
the word you're getting from this that they're saying is electromagnetic waves.
when they say
Like, where are they
gravitational
saying
waves,
that?
when they say gravitational waves, that's essentially what they mean, because they're making that up. Everything in this paper is made up. The conclusion of this paper and all the other papers, right, is that at the end of the day, we don't fucking know. We don't know. We think it's this, that, and the third. But then when we look at thunderstorms,
we'll
there's
get
an
to the end and
effect
we'll see if it
on
concludes
our
that
other
we don't know
magnetic
anything.
fields that we can't explain. You know what I mean? And the only thing that
Okay,
makes sense is that
Okay,
well, we'll get to the
it's
end
only
and we'll
like
see if they conclude that they
we're
don't
gonna have
know
to do it.
anything.
We're gonna have to
No
do it
problem.
quick
They
though,
believe that
man. You know what I
acoustic.
mean? Like I said, I'm
Okay,
like, that's
and
because
I
I'm
lost track of where I was.
yeah,
Hold
I
up
don't know
here.
how much
it's only
Like
like
how much time you got
irregular.
left. You feel me? But we're
Okay,
gonna, you know what I mean?
and I said
this
to believe that acoustic
and I lost track of where I was. Hold up here.
the
Okay,
propagation of
here,
these waves from the
irregularities.
atmosphere and has found that a
Okay,
window can
whatever.
exist
And I
for
said
discussed about the these waves measure troposphere. What has investigated the propagation of these waves from the troposphere and has found that a window can exist where waves can be generated in 2 hours. Federal laws of mass of energy can sometimes flow out of the troposphere. Although Gossett discussed several mechanisms by which such waves can be generated, he did not suggest any mechanism by which a thunderstorm could generate acoustic waves. Shepard also suggested mechanisms to review certain known features of thunderstorm formation. Thunderstorm cell stage the upward and updraft extends throughout most of the cell. And these updrafts are generally in the order of 10 seconds, but may locally. So it seems that you were incorrect about what an updraft is.
The
It looks
driving
like they're
force of
literally
updraft
talking
seems to be
about
an instability
movements
of
of air
atmosphere.
upward. So it seems that you were incorrect about what an updraft is. It looks like they're literally talking about
It's very
movements of
possible.
air upward.
It's very possible. I pulled the definition out of my
in a
ass.
region near the ground where locally the potential temperature decreases with height in air.
So, if this instability occurs in a region near the ground where locally the potential temperature decreases with height, in air in the lower near rise is called the updraft. Talking about air moving upward
The level is
at
reached where the temperature
what it
is
says
not
between
change in
10
avionic
feet per
expansion is
second
equal
up
to that
to
of the ambient
exceeding
air at the
100
same
feet per
altitude.
second.
In the air,
The level is
rises
reached
may
where the
cause
potential
emission of
temperature,
water
which is
vapor, and
not
this condensation
change in
builds up
avionic
energy
expansion,
to
is
which the
equal to
air
that
in
of
turn
the ambient air at the
increases
same
with the
altitude.
temperature,
The
cause the
air
driving
that
force of the
rises may
updraft to be
cause
more
ignition of
intense.
water vapor, and
Equilibrium
this
height and
condensation
unstable air
gives up
increases
energy,
the effect
to which the
of
air
temperature
in
stabilization
turn
of height.
turns increases
As
the
unstable air
temperature and
rises
cause the
with
driving
height,
force
then
of
it
the
overshoots
updraft to
this
be more
pull
intense.
back, and that results in
Equilibrium height and
oscillation of
unstable
the
air
air.
increases
At
the
its
effect
absolute
of the
approximate same
temperature
height
in the
as the
stable
cloud
changes
top,
with height.
superior to
As
oscillation
unstable
of
air
the
rises
sustained
with height, and it overshoots this and be pulled back,
is
and
a
that result
particular
is
for Fiberic
oscillation in
velocity
the air.
pressure.
But at
The
absolute
observed
approximate
by
same height as
through
the
the
cloud
length of the
top,
curve of
superior to
vertical
oscillation
velocity
should be
from
about
this
the same
cloud
as that
top
of the
vertex derived
period.
from measurements
That
taken
is the
photographed
particular for
from
vertical
present
observed by the example of the curve of vertical velocity from its cloud top vertex derived from measurements
Anderson
photographed.
measurements
Example.
particularly
So that's
Bear with us, everybody, as Daryl gets up to speed. Bear with us.
Anderson measurements are particularly suggestive.
I still haven't seen where it said what I heard you say they said, but so right now they're talking about basically
I still haven't
giving
seen
and
where it
exchanging
said
energy.
what I heard you say they said, but so right now they're talking about basically the giving and
I
exchange
was
of
very
energy.
honest and
Let
clear
me
up
ask you
front.
this
I
real quick.
wanted to see the article
What
to
are
see if
we
it's
hoping
saying
to
what you're
get at
saying
the end
is
of this?
saying.
What are we heading toward? Just so we can.
I was very honest and clear up front. I wanted to see the article to see if it's saying what you're saying is saying.
But I
Do
respect
you
that, but you're
agree
gonna have to do
then
that on your
that
own
this
time. Like, we're
article
not
does
gonna
not
sit
say
here and
what you
just
said
listen
it
to you
said?
read. You know, that's not very interesting. You know what I
Okay,
mean?
then we
Like,
should.
if you're not sure,
do you agree then that this article does not say what you said it said?
no, I don't. But if you're
Okay,
not,
then we should continue to
just a
see
little
if
bit
it
here.
gets to that point.
I don't want to sit. I don't sit here and listen to other people read. Like, that's not interesting, right?
We only
Even
have
though
what, like
even though we
this
are,
little bit
even though we are
here.
trying to get to the bottom of it, we also want to make it interesting for the people who are watching, right? So let's not like if you're not sure about what I'm saying, let's move on from that, right, to something that maybe you are sure about, so that way we can maybe make some
Let's
ground.
think
Because you're
about this
reading this
for
for
a
the
second.
first
Let's
time.
think about
That
this
doesn't
for
mean
a
you're going to
second.
understand it on
You
the
just
first
said
time,
I'm
right?
reading it for the
Let's
first
just,
time.
you know what
That
I mean?
doesn't
Like I
mean I'm
said,
going to extend it.
I literally
Let's
pulled
think
up
about
the
you haven't
article.
read it at
Let's
all,
think about this
and
for
you're
a
making
second.
proclamations
You
on it.
just
So how
said
do you
I'm
think
reading it
that
for the
that
first time.
relates? That doesn't mean I'm going to extend it for the first time.
Yes.
You haven't read it at all, and you're making
Yeah,
proclamations
yeah.
on it.
No,
So how do you think that
it's
relates to
basically
it?
me. It's basically me, and I'm admitting this. It's me cherry picking articles, right, from scientific journals that fit what it is that I already know through experimentation. Notice I didn't bring those up as evidence, right? I never brought a single paper up as evidence. You wanted me to bring it up because I get it. You're part of the paper worshiping scientific, you know what I mean, cult or whatever, right? You guys love paper. So I brought it up for you guys, but it's still not evidence. It's just a piece of paper. Anybody can say anything on a piece of paper. That doesn't mean anything.
It's just a piece of paper. Okay, sounds good. So why don't we do
that's
this?
why I brought up the videos and examples of people actually in the field doing the actual work, talking about what they're actually viewing in real life.
You had mentioned,
Paper's not real
you were
life. Paper's
saying
just
that
paper. It might as well be the Bible.
science
You know
is irrelevant if it doesn't improve light.
So
the
normal person.
another thing you had mentioned, you were saying that science is irrelevant.
So I wanted
if it
to
doesn't
ask you
improve light
a
of
question
the normal
that,
person.
Absolutely.
I remember you had mentioned Witsit. I remember
so I wanted to
DSC
ask
a
you
while ago asked
a
Witsit this
question
question.
that he sort of ran away from it.
Because I remember you had mentioned
If you have a ball that's dropped
Witsit. I remember
from 10
DSC a
meters
while
on the
ago
ledge,
asked Witsit this question. He
what
sort
is
of
the
ran away from
object's
it.
velocity
If you have a
before it hits the
ball that's
ground
dropped
from
and
10
show us how
meters
you
on the
calculate
ledge?
that with
What is the
what
object's
you were saying
velocity
about the
before it
generation
hits
of
the
electricity
ground?
and show us how you calculate that
Grabbing
with
magnetic fields and how do you
what you were
calculate
saying
that?
about
Like
the
show
generation
us
of
the
electricity
way that's
and
calculated and the formulas that you derive and
grabbing
how that's
magnetic
done
fields and
to get
how do you calculate
the
that? Like
velocity of that thing when it
show
gets
us the
down.
way that's calculated and the formulas that you derive and how that's done to get the velocity of that thing when it gets down.
Okay. Well,
No. I'm not asking
I'm gonna
a
see if I
photo.
have
I'm
a
asking for
photo in
you
here
to
that
actually utilize
does
this.
break this down mathematically.
No.
But
I'm not asking a photo. I'm asking for you to actually
I'm
utilize.
not a mathematician. I'm not a mathematician, so I don't know why you're asking me that. I don't know. But I can refer you to the mathematicians that I look at when they describe this, right? That's what I do. Especially if I'm completely lost, right? I'm going to assume that the people that get respect in their field, right, at least know what they're talking about when it comes to math. And so what I do is I look at people on both sides of the issues, right? People that agree with me and people that disagree. And then I cross-reference between the two. That's how I research and figure out what's going on. You take people that agree with you,
I'll
people
take
that
a look
don't
and see
agree.
what you have.
I'm gonna see if it's in here because it might not be. Like I had that debate last week, and I have like literally 1,000 things. Okay, here we go. Yep, I got it right here. I mean, this is like I said, you have to be a mathematician to really understand this, but this is straight from them. Hold up. Give me a quick second. I got to email this photo to my. As a matter of fact, I'm gonna send it to you on Instagram right now.
Okay.
That's the quickest way I can get it to you. Yeah.
That's fine. Should be able to get it in. I'll share it.
Fine. Yeah. Because it'll take me a minute to send it to my email, and I got a lot going on my computer right now.
Fine.
All right. So I sent you a photo. That's basically taking the a kinetic equation, right? That basically is.
And I apologize. Give me a moment. Let me pull it up so I can see what you're talking about. Hold up. I'm still working through it, and I could download it to show the people as well. So they know what you're talking about as well. One moment here. Looks like this is the. What looks like this. Looks like it's not. Hold up. Window. Entire screen. Okay, there we go. I can show the entire screen. All right, here we go. Okay, so what are you saying this is doing again? Now everybody can see it now. I'm not clear what you're saying. You saying this bottom equation here? They inserted this for gravity. I'm still not clear about what you're saying. I apologize. You saying they're measuring the same thing? Mhm, mhm, mhm. Mhm. Right. So maybe I'm understanding properly. From what you're saying, this is showing that the electricity, like the force of the electromagnetic force, works better than the force of gravity. So this weight right here. What are these weights talking about? What would you say? I'm not asking you a mathematical question. I'm asking this. You don't know. And you get that from this image right here. But you get that from this image right here, all the conclusions you put forward just a moment ago. I mean, this image is what informs you of that, the things that you recently said. All right, I hear you, man. So let me scroll through and see if there's anything else that sticks out from uh that I make sure I'm understanding properly. Earlier, you said that you're unable to calculate the fall of that thing that I discussed earlier. I understand that you can't do it. You said that science is irrelevant if it doesn't improve life of the normal person. So what technology is in existence now that's based upon the understanding that you've put forth? Any understanding, whether it's gravity, quantum mechanics, all of it. Mhm, mhm, mhm. Mhm. Right. Right. Well, let me ask you this: our construction technology, like skyscrapers, what is the true way then that they construct skyscrapers? What's the true thing that stops them from collapsing? Huh? Yes. But I'm asking is how does what is the real? Because obviously, from what you're saying, the way they say they build these things can't be true if it's all based upon this magnetism and electricity thing. So, what's the actual way these things are constructed, and how do you know this? I think. Hold up. Wait, but I think. So let me just back up. To make sure that we're on the same page. You have said, and it's very. That seems like a very relevant thing to say. You said science is irrelevant if it doesn't prove the life of a normal person. I mean, I wouldn't 100% agree with that because that's pure science, but I understand the idea, right? Think practical. Yeah, I mentioned practicality, right? So I asked you what technologies, what things in the world, what things that improve people's lives is based upon your understanding. What things in the world, what technology, what things are built. And you said everything. So that would include buildings, that would include computers, that would include airplanes. You said everything. So I picked one thing out of everything, and I'm asking you, how is this built? Yes. No, no, no. I'm saying the structure of the building itself. I'm not talking about electricity. I'm saying you build a skyscraper, it doesn't fall. How? I don't want to go into history. I'm asking, how is it really built? Okay. All right. Gotcha. Now, I remember you was mentioning that one of the guys, the two guys that you mentioned at first, uh, the two, I didn't pay attention to their names, but are they like physicists or the one was on Lexus? So they like PhD physicists? All right. And one of them you were talking about how quantum physics that's going to be thrown out the door as well. It's not you explaining all the different words to me. Let me ask you, and you were saying like electrons don't exist and it's movement and where things are. So like mhm, okay, okay. So if you have a particle, a subatomic particle, how do you or how would you determine the amplitude of its location and how is the way they're actually doing it wrong? Like, let me know how the way they actually do it is wrong, and then what's the real way it should be done, or the real way is really being done behind the scenes if we knew what was really going on. So I'm not asking about that. I'm just saying you wanted to find the location of the particle, the most probable location of a particle. What's the real way? Okay, okay. Mm-mm.
And I want to be clear. When you say they're assuming when you're saying they're assuming these things, are you saying that you read in their papers they're assuming this, or you heard them say that, or are you saying they're assuming it? Okay. Mhm. Mhm.
Those two. You understand? So that
And,
I don't know if that answers. That's the long way, but it's like that's how, right? The idea of looking at everything as just one thing rather than looking at everything as all these different things, it works better from what they're seeing in the collider and their mathematical equations when they're trying to explain what they see.
did I hear you say that light? Did you say light is not a wave or it's not a particle? What did you say about light?
Well,
Either
I'm
here or
saying that when they do the double slit experiment,
mhm.
that was them proving that this is their explanation. Before we look at it, light is a wave, and then it only becomes a particle when we see it. I'm sure everybody's familiar with that by now, right? Because when they do the experiment and they get the interference pattern happens as if light is a wave. But then when they're watching it, it acts like a particle, right?
Mhm.
I don't know. I don't know if you know who Henry Poincaré is, right? But Henry Poincaré, right, or Henri Poincaré, however you say that dumb French name.
Mhm.
He's the one that that Einstein took the theory of general relativity from. He literally says, "It is not the universe that imposed space and time on us, but it is us that impose space and time on it." And this is congruent with what scientists are seeing in the subatomic particle colliders, right? They're seeing that, okay, these things act in a way that there is no space time. They're acting as if it's just one, basically, it's just one medium moving at different shapes and frequencies.
Okay. So what's really then going on with the photoelectric effect?
The photoelectric effect.
Mhm.
So you're talking about light then? So you're saying like what is light?
Okay. Well, why don't we put it another way then? What is it that's actually so when you say light goes through the when they watch light, when they see light, that's what causes it to act like a particle? What exactly is it? Are you saying that causes it to act like a particle?
Right, when they're observing the experiment. So the experiment happens, right? And then they can see the result of just to make it simple. Obviously,
Mhm.
it's more complicated than this, right? But this is the
Mhm.
simply put. They run an experiment.
Mhm.
After the experiment, there's a pattern on the back wall, right, of the experiment that lets them know what happened. So they can watch the experiment and then see the pattern, or they can not watch the experiment and just let the pattern happen. It's very simply put. When they do that, right, when they don't
Mhm.
watch the experiment, but they just look for the pattern after, light acts like a wave. It's not a particle. And and their explanation is that it turns into a particle when we look at it. They saying that light, they're saying that the particle is sentient. Do you understand what you believe in? Or not you, but the people that are saying that light is a particle. They're saying
So
that
let's see that.
the
Let's see
particle is
that then.
sentient. Hold on, let me finish this. Let me finish because
Okay.
this is crazy. They actually believe the light particle is sentient. It knows when you're looking at it, and it's like, oh, he's looking at me now, like the WB frog. They're saying the light particle is the damn WB frog. That's crazy. More than
so let's
likely,
see
it's
that then.
away the whole time.
Okay, let's see that then. Let's see the paper where they say that or at.
You never seen the double slit experiment before? I'll pull that up. I'll pull it up.
No.
I'm
I'm asking. No. I'm asking about. Wait. I'm not asking about the double slit experiment. I'm asking you to pull up where they say the light is sentient. I'm asking you to pull that up so we can look at that.
I mean, I'm not gonna do research on stream right now to find a paper where it says that. You either have to take my word for it or go prove me wrong later.
So to make sure I'm
But
understanding properly.
I can show you the double slit experiment.
Wait. Let me make sure I'm understanding
you'll
properly.
See, but this is what I'm saying. You'll see that in the experiment, at the end of the experiment, their conclusion isn't, well, it must be a wave then. That's not their conclusion. Their conclusion is, well, it's still a particle, but at some point in between when it shoots and when we look at it, it turns into a particle. So maybe they don't use the word sentient, right? But I'm saying that essentially that's what they're saying. They're saying it turns into a particle when you look at it. So either I have the power, I have the power to affect microatoms of light to turn it into something. Either that's what you're saying, which is like you're saying we're in a simulation now. So basically, this is fully a simulation, if that's the case, or you're saying that the light beam is sentient and it knows when it's being looked at, and it doesn't want people to see what it really looks like or something. It makes no sense. It makes no sense at the end of the day.
So to be clear, you're saying you did not read a paper where they said the light is sentient.
No, I've never read a paper. I don't worship paper. Okay, I listen to scientists talk about their discoveries in their experiments. You know what I mean?
So you heard a scientist say the light is sentient.
Yeah. Well, no, I told you maybe they didn't use the word sentient, but they said clearly at some point between us looking at it, right, and it leaving from where it was shot from, it decides to turn into a particle before we look at it. That's what their official explanation is. Yes.
Sure.
Right, and you're gonna have to just take my word for it. All right, go do your research on your own time. You feel me? That's why, like, I literally spent all day today and yesterday. Well, I got a debate on Tuesday, so that's why I do that. But like, I've been reading and researching this all day, getting ready for it. You know what I mean? So, you know what I mean? It's like I can't. You know, it's you know, you got to do that on your own time, my brother. You feel me?
Okay. You have said that masses are attracted to the incoherent magnetic mass of the Earth.
Yeah, magnetic fields are attracted to incoherent fields, right? But the bigger the field gets, the weaker the attraction gets. So it basically, you know, like people say, like, well, if Earth is a magnet, right? Then how come when you flip your field to the other side, you don't fly off, right?
But I'm just saying, like when I drop something, that's what's happening. So, but you don't have any equations or anything to calculate.
No. We have real life experiments. We have real life experiments.
Okay.
Yeah, real life proof and experiments that yeah.
So how do you suggest that that the kinematic equations and things are able to do that, like able to calculate how long something will be in the air for, like a projectile, or how fast a block will slide down a slanted plane? How do you account for that?
How do I come to that?
Are you aware of that that is a thing?
Well, yeah, that's what we were talking about earlier. I mean, they basically. This would just be me assuming, because I'm like, this is what would make the most sense, right? That if you can basically calculate the rate of the rate of movement between magnets, right? An average rate of movement, like you take 100 different magnets, right, that all have different strengths or whatever, and you take the average rate of movement, and then you create an equation from that. This is just me pulling this out of my ass, I swear to God. So I'm saying this would just make the most sense. I don't know if this is how they did it, but you could do it like this, right? Come up with an average of the rate and see how that works in place of quote unquote gravity.
Right. Well, I appreciate you speaking with me, man. It's pretty much all the things that came to mind. Like I said, I just want to get an understanding
a better understanding of why you hold your position. And I think I was able to accomplish that. Um, I'm fine if you, before I go, if you want to ask me questions about something or anything.
Yeah. What was that? What was the first question I asked? I asked about you believing, right?
Okay, yeah,
Oh,
yeah.
do you remember the question or?
Yeah, basically, do I believe in or abide by the mainstream idea of the way the world works, basically?
Like, just to make it split, like, do you believe that just because it's in a peer reviewed paper that it's something that is accurate or is technically scientific? Like, what is your ideas about the scientific method?
Okay. So, my understanding of the scientific method is basically this: people do research, do experiments, come up with theories that are then tested in various ways. They publish their results, is subject to the peer review, and the things that uh, withstand that test or become established law. That's basically the gist of it. Just because something is in a paper, do you believe it? No, no scientist does that. That's why when somebody puts a paper out, people test it and try to disprove it. So things are only accepted after they are verified. So papers are not like a Bible in science.
Yeah, well, I mean, I'm not gonna lie. It seems like a lot of people treat it that way, because people have a very, very negative reaction to, I mean, me just bringing up simple experiments that prove something, and then when they're trying to debunk it, they never bring up experiments on the other side. You feel me? They're just always trying to poke holes in what it is that I'm saying, and I never hear like, okay, well, you know why that's wrong? Because look at this experiment, right? Here's this experiment of proving blah 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 blah. You feel me? Or if I bring up a quote of of Einstein saying his biggest mistake was throwing out the idea of the ether in general relativity. If I bring up a quote of him saying that, nobody ever says, "Hey, here's another quote of Einstein saying, hey, you know the other quote I said? Yeah, I was just bullshitting. I didn't really mean that." It's like I'm sometimes I get confused, right? When when people get upset when I call them religious and I say that they worship paper when they clearly do. You know what I mean? Like I said, even like think about it, all the experiments that I brought up, right? As soon as I brought up the or when you asked me about the papers and I brought them back up, you were like, "Oh yeah, let's bring the paper up, let's read it, let's see if it says what you like." You were so interested in whether or not that paper said what I wanted it to say, as if that even matters. It's like, who gives a fuck? If it says it or it doesn't not, if it doesn't, it's a piece of paper at the end of the day. And if we are taking it as gospel, then now we're worshiping it like a Bible. You know what I mean? So I actually don't believe that peer review papers are number one valuable, useful. I mean, I don't think that there's any credence to any form of appeal to authority. You know what I mean? So I get confused when people claim to be quote unquote scientific and they want to hold my feet to the scientific fire to the scientific fire, but at the end of the day they're just appealing to authority the whole time. What does this paper say? What did this person say about it? It's like, well, it doesn't really matter. Like, what does the data say, right? What does the data say? And then I want to hear different people's perspective on what they're taking out of the data, if that makes sense.
Here.
Yeah, I don't think man, it's crazy that this other video that I had was so perfect too. It literally like showed you step by step, like let me try one more search.
Okay.
I literally watch like a million lectures a week. Hit him with a hammer. Either way, anybody listening right now, go look up incoherent magnetic fields. If you look up incoherent magnetic fields and you do just a little bit of research, all right, it's going to take some time. You're not going to be able to look at the first 5 videos or the first 10 videos. You're going to actually have to do some research, and you'll find some good content where people are giving you examples on how magnetic fields work on each other. And then when you group large fields together, they give you one second. When you group large fields together, right, they show you how certain effects would take place and how it literally looks like exactly like what we experience on the earth. See, this is my main thing is if you want to believe something about the earth, right, or about the stars, then you have to be able to replicate it in a lab, right? If you can't replicate it, then your opinion is not really scientific. You know what I mean? You know, so that's why, like, you know, when I was in the debate and you know, we were talking about matter of fact, that might have been the after show actually, but when people talk about stars and stuff, right? I'm like, okay, well, what are? I think that was during the debate. I'm like, okay, Leo, what is a star then? What do you think a star is? He starts explaining what it is, and I'm like, okay, well, has that been replicated in a lab? Has anybody replicated that in a lab before? No. Okay, so how do you know it's that? How do you know that's even possible? You don't know that's possible, right? Okay, so but when I say that everything comes from sound, right, and everybody gets all upset, right? Oh, what are you talking about, right? I'm like, yeah, everything comes from sound, right? Because everything is basically just light, condensed light, right? And then we can prove that light comes from sound, sololuminescence, right? So that we can actually get a jar of water, right? You can do this at home. You can use sound or electromagnetic frequencies, same thing, and you can shoot it at the water and you can create a star. You can create light that looks exactly like what it forms exactly like what we see in the sky. It's a mixture of water and sound, right? Okay, so if that's my hypothesis, right, and I have shown it in the lab, and you guys have a hypothesis and it hasn't been shown in the lab, I'm sorry, we got to go. We got to go with what I think. As far as I know, I'm the authority right now, or whoever is on the side of the people, right, that are appealing to experiments and stuff that we can actually replicate on Earth. You know what I mean?
To make sure I'm understanding properly, your position is that stars are light and sound because of that.
I'm saying that everything, and sound is just another way of saying electromagnetic frequencies or energy, right? It is. It's just frequency and energy. And so, yeah, I'm saying that like everything that we see is essentially condensed light, right? That's why they don't know, right? I mean, like I said, the particle colliders are proving some of this, right? But everything that we see is essentially condensed light, right? And when you get all the way down to what light is, you're going to just start to see different strings of electromagnetic frequencies, which essentially is the same thing as sound. You know what I mean? Like your body, right, is essentially just one big electromagnetic field. You're like, you know how people say like we're vibrating over and over. Think about it. To say that something is vibrating is the same thing as to say that something is making a sound, so you're just one big sound. We are just one big sound. I mean, like, this is heavy stuff, but it's like we're a frequency. We're a certain, you know what I mean? We're a certain tunage or whatever, or what we describe as tunage, because that's just our basic Neanderthal way of understanding what we're seeing and what we're picking up. It's just our user interface. You know what I mean? It doesn't say anything about what's really going on under the hood. God dang it. How can I not? Like, I swear to God. Anyways.
No problem. Well, it was nice talking with you, man. I appreciate you taking the time to speak with me.
Yeah, I appreciate you too, man. And like I said, man, you know, you're more than welcome to come on anytime. You feel me? You know, I always like to, invite people to come on and challenge my opinion whenever it is, that they can, especially if they've proven that we can have a cordial conversation. You know what I mean? So I do appreciate you. I do appreciate you being so inquisitive. I like how slick you were. You feel me? By avoiding most of my questions.
Well, hold up now. Let me know a question I avoided. Like I said, when I said earlier, let me know any questions you had before I go. I didn't want to be just here, just ask you a bunch of questions and then leave without you having. So you asked me about what I thought about science. I answered that. What other question did you ask me that I didn't answer?
Oh well. I mean, just building upon that, right? Now, when you look at so do you believe that if there's an experiment that shows that something is possible, right? In order for you to assert that something else is possible, do you think that it needs to be shown through experimentation?
Give me a specific example so I can understand what you mean.
Like the star example, right? Like if you say stars form because of gravity, And I say stars form because of sound, right? And I show, right, through in a lab that stars can come from sound, and you never show, or if I show that stars can come from sound, in order for you to challenge my scientific theory, do you have to show in a lab that stars can come from gravity?
Okay. Well, perhaps it's my fault that I didn't give as much attention as I should have to what you said about that. Okay, so the lab showed that stars from sound. So the particular star that was made, it's possible. Okay, the particular star that was made, what was what was the spectroscopy on the light that came from that? Like what elements were in that star, and what was the concentration?
I'm gonna pull it up for you right now.
Okay.
Sonoluminescence. The first time I saw sonoluminescence was in a darkened room.
Yeah, so this is it right here. Right.
Seth Putterman called it the star in a jar. A tiny.
Okay, so basically, right. So when we look up in the sky, right, we have no idea what we're looking at, right? Because we're down here. We've never been up there. Oh, I got another question for you too, since you used to work for NASA.
So let me be clear. I don't want even to be mistakenly misrepresented. I never worked for NASA.
Oh, I got
I was a community college student, and I was in the NCAS. It's called. So let me just give a bit more detail on that, so there's no lack of clarity. So if you're a community college student, you can sign up as for this little program that they have, where you can learn. You can spend a few months learning about NASA. NASA people come and speak to you, but you're a community college student. You read some things from NASA, hear some things. If you pass the first section of it, then you can join the second session where basically you do this mock project where you plan a space mission. We planned a space mission to the moon. It's sort of like a game, and then at the same time you're working with other students, and you end up presenting your project to some NASA people at the end. But it's basically a way for community college students to learn about NASA and potentially help them become an intern if they want as a NASA. But I was a community college student. It was sort of like a not really an intern, but I guess that's the closest I can relate it to. It was a learning experience. But I never worked for NASA. It would be nice if I did, but I never worked for NASA. So I don't want anybody to think I misrepresented that.
Okay. Sorry about that.
Right. No problem.
I stand corrected. But like I said, so if we look up in the sky, right, we have no idea what we're looking at. All we see is lights in a medium that we have no idea what it is. So if I can recreate that, right, I'm saying that is what I've recreated right here, right? And you say, no, that's not what it is. Do you have to be able to recreate that in order to challenge my scientific theory?
Well, I'm still at the point of trying to understand if that's what you recreated, right? So in other words,
I mean, as far as we know, like visually, it is, because we don't know what the stars are. All we know technically is that they're lights.
Okay. So in other words, then what is wrong with the spectrometric data from stars? I don't know the proper adjective. But so how is that wrong? The data from spectroscopy about the elements in stars, how was that wrong? And how did you recreate that, or what elements did you find in this light that you saw? Either how is that wrong, or what
it's all
elements
theoretical.
you see in this?
It's all theoretical, because you can't collect particles from something that you've never been there. So it's literally just all theoretical. People are just claiming
it's all theoretical. So what is really going on then when you send energy into, let's say, a lamp full of hydrogen? What are those lines that you see in the diffraction gradient? What is really going on there?
Okay, you're saying when you send light,
if you have an electric lamp of hydrogen, for instance,
okay,
and you look at it through a diffraction gradient, and you see the spectrographic lines, what is that? What's really going on there? If it's all just theory, because obviously what they're saying is going on can't be real. So what's really going on there?
I'm saying that everything is just different electromagnetic frequencies interacting with each other, and as they take
I'm asking a very specific question. I'm asking a
I'm
very
telling you,
specific
I'm
question.
telling you what my answer is. As they take very specific forms and interact with each other, they change shape, which codes, right? Like the guy said, these different shapes become coding for locality and basically how we identify things, right? We see things at certain places in certain shapes and at certain colors because of the certain frequency that they're on. So I'm saying all we're seeing is changing in
Okay,
frequency.
okay. So what colors, what colors and what lines did you see from the light in the draw there? What lines were emitted from that?
What lines were emitted?
What spectrographic lines were emitted from that?
I can't answer that. I don't know.
Okay. All right. So the spectrographic lines that we do get from stars, you're saying that's just is not really elements. It's not. We're not seeing the light from the elements in the stars.
I'm not saying that anything that we see is not there. I'm just saying that what they're describing it as is obviously not what it is. And if it is, then shouldn't we need to see some experimentation that shows that in order for
Well,
it to be scientific? It can be
I
a
guess
good
this is what
theory.
I'm trying to get at. Were you able to get a spectrographic series of lines from from the star in the bottle, just like how we can get from the various stars? Were you able to get that or not?
No, I didn't run the experiment, so I can't answer that specifically. I don't know.
Were they able to get that?
You'd have to go look that up for yourself. Yeah, I don't know.
So
I mean,
you
there's like
don't know if they were able to get
there's
that.
hundreds of different times that experiment has been done, so it should be
Okay,
easy to find that information. Yeah, I'm not sure.
okay, you're not sure.
No.
Were they able to see activity on that star in the bottle, like sunspots or sun flares, similar to how we see on the sun?
Sunspots or sun flares?
Hmm.
I don't know about sun flares. I don't know if that's confirmed or not. Because as far as
Solar
we know,
flares.
the sun is basically just like a lamp. The sun is just a light in the air. Like we've never been on the sun or anything.
So you're saying there's no such thing as solar flares?
I don't. It depends on what they're trying to say that it is. I don't know enough about solar flares
Okay.
to break down what it is that they're talking about in plain language. Because I
It,
like
it,
people have jargon, right, to
problem
explain things.
is
Everything really is simple. So I don't know
is
what
there
the
such a thing
jargon
as
is so
sunspots?
specifically.
Is there such a
Sunspot.
Mhm.
So you're saying like when they take a picture above the Earth, how the sun is pointed on one spot?
N- No. Okay. So what I'm understanding is that you did not verify that the thing in the jar is the same thing as what we see in the star. So that mean that the question that you asked me
Well,
is
well,
not a
well,
valid
well, well,
question.
well nobody can verify that because we don't know what it is that we see in the stars. We
No,
don't
no,
even know what
no,
that
you're missing
is
it. No,
to
you're missing it.
verify.
You're missing it. I can look up. Do you agree that I can point a telescope at the stars or at the sun and look at them, and I see something?
Yeah, yeah, you see a light. That's it.
Have you ever looked through a telescope at the sun or at the stars?
I have looked at a telescope at sun, stars, and planets. And those planets, like if you look at planets through telescopes, they don't look like what they tell us stars are at
No, no.
all.
So have you? So you looked at the sun through a telescope?
I don't know if I've looked directly at the sun through a telescope. No, I look at the sun every day though. I'm a solar gazer, so I look at the
Okay,
sun every day.
and it's just the light,
Huh?
and it's just the light.
I mean, apparently, right? It's the
Hey,
same
man.
thing. Like think about it. Like the sun is the same. It has to be literally the exact same baseline substance that are these lights are, right? The lights that's shining on me right now. You know why? Because if I took a plant, right, a baby plant, and I put the plant in here under the light, the plant is going to grow exactly like it would under the sun. It gets the same energy from this light that it does from the sun. It doesn't, whatever they say the sun is, right? Fire, gas, or all these things. I could take those things and put them next to a plant. The plant's not going to grow from that. So how could the sun be that if the plant doesn't grow from that? The plant grows from the sun. Or electricity, because the plant is electricity. So the plant needs more electricity in order to get energy, just like us. Everything is electricity. So electricity comes from this light. That's why the plant can grow from this electric light. Electricity comes from the sun. That's why the plant grows from the electric light that is the sun. Whatever the sun is, it's electricity coming off it.
All right. Well, let me just make sure to wrap it up so it can be clear that I tried to address your question, but the what I'm seeing that's causing the question to be an invalid question is if I'm going to say, okay, you created a star in the lab, so now
do you have to recreate what I see out there in the lab? You haven't shown me that you created a star in the lab because you don't even know the characteristics of stars to even know if it was a replication of a star in the
Right.
lab.
I
So
agree.
you
We're
can't really
just
say
going.
that you created what we see in the telescope in the lab. So
I mean,
do you have any other
it's a
questions
lot
that I
closer.
missed there?
Well, yeah, but it's a lot closer than anybody else has been able to create. Nobody's even come close to being able to create anything that looks like what we think the stars are. So we don't know
Okay.
what it is. You're right, but at least visually, I can at least create something that visually represents what we're seeing. There's on the
Interesting.
other side, there's not even anything that visually represents it.
Okay. So since you were able to create something that visually represented it, what were the frequency of the sunspots on the star in the jar? And what was the direction of rotation and the rate of rotation of those sunspots and the frequency of how often they came about?
Yeah, I'm not sure. If you want, I can do some more research and we can dive deep on that next time. I'll have to
All right.
read
So that means
specifically on that.
so that means that you can't say what you just said. You just said you created
I
it, but
can say it. Well, I asked you a question because at the end of
and
the
I
day,
apologize. When I say that you can't say it, I mean you can't reasonably say
assert it.
what you
Yeah,
just
I
said
get what you're saying.
because
But
you don't have any basis to say that.
right, well, but it was just a question, right? So I'm saying if, right? 'Cause I'm not saying we can't, because even if we could prove, right, that we created exactly what the star was, that doesn't mean that that is how they were created. Just gotta prove that it's possible. That doesn't mean that that's the process that took place. So even if I could prove that, it's still not evidence. So I'm just asking if, right? If I theoretically, right, could do that, right? And you're saying that no, I think it's this way. Does there need to be an experiment on the other side for you to even have weight to be able to disagree with me scientifically? Or
I think if you created a star in the laboratory and based upon your understanding of what things are, then that would definitely bring up some questions. Yes.
okay. All right, last question before I know you got to get out of here. Do you actually think we went to the moon? Well, okay. First of all, I want to preface it by saying, because a lot of people don't know this already, and I got to bring everybody up to speed. Let's not argue over the facts, all right? The facts are NASA admitted that they faked the moon landing, all right? Let's be clear. That doesn't mean that they did not go to the moon. For all you guys listening, that does not mean they didn't go to the moon, but it does mean that they did fake the moon landing. They admitted this, all right? They like the Chili Pepper said, space might be the final frontier, but it's made in a Hollywood basement. All right. Sorry. They admitted that already. So since we know that they admitted that they didn't go to the moon, that they faked the actual footage of it, do you think that they actually went to the moon?
Well, I guess when I think about whether they went to the moon or not, the first thing that comes to mind is the reflector that's on the moon. So the reflector was put there as being utilized by people, so that tells me that they went to the moon.
I hate to do this to you, my brother, but how do you know the reflector's there?
All right. I know that flat earthers are
I'm not a
very
flat earther.
big about
Continue.
uh, 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 it seems like the thrust of your position is simply trying to sow doubt. I don't really play that game.
Trying
People,
to do
this is
what?
the I don't really play the game of how do you really know it's there, and it's so in doubt and
Well,
distrust.
you've been doing that
I
to
don't
me
really
this
play
whole
that game.
time.
In what way exactly?
Isn't that what you've been doing to me? Well, how do you
I
know for
know.
sure? Does the paper really say that? Well, let's pull the paper up. We sat here and read the whole paper.
No.
Like,
No.
I'm confused.
Let's compare. You had said they created a star in a jar. So I asked you details about that. Okay. You said
I'm
this
asking
paper
details about.
supports what you said. Asked you details about that. That's totally different from saying, well, how do you really know that they went? That's sort of a
How is
could you
that,
really believe them?
bro?
That's
How
totally
is that
different.
totally? It seemed like you said the same thing to me. You asked me details. I'm asking you details. What do you mean they have a reflector up there? How do they know that the reflector was up there? How do they know? That's all I asked. And you see this, but this is back to my point about you guys always, or not you guys, but people pressing me to be scientific. But then on the other side, they don't want to be scientific at all. You just want to
This is
take
what I mean.
the appeal to authority.
This is what I mean. If I say I talked to somebody who shot a beam to the reflector, well, how can you believe them? They could be lying. How do you know that the system wasn't fake? There's no end to that. That's totally different
There
from
is an end to that. I disagree.
there's no end
I
to
think
that. I don't
the
think
end.
put
You
it
know
like
what
this.
the
I
end
don't
is?
see an end to that.
I don't
The
see an answer to
scientific,
that.
the scientific method. Well, dude, the scientific method is the end of that. That's why I always am stringent on not considering anything science unless it follows the scientific method, because those are our checks and balances. If you say something happened, right? Think about it. Even if you do an experiment and you come up with a theory, you know what the end of that is? It has to be testable and repeatable. They always forget that part on the debates. Where is the repeatable? Huh? Where is the repeatable? If you do an experiment and you want me to believe you, I have to be able to do it too. And don't tell me it's too expensive, because now, you bullshitting. You lying. You lying now. Yeah, that's right. Life is not so complicated that the average person can't understand what people are doing scientifically. It's really not. All right, so look, if there's an experiment, then I should be able to do it too. And if I can't, then as far as I'm concerned, y'all lying. It's not scientific. So that's how you end that. Oh, you don't believe me? Well, then do the experiment yourself. That's how you end it right there. That's why in my debate, I said, look at this experiment you can do with this telescope. Boop. You can do this experiment at home. Look at the Michelson and Morley. That experiment is a little bit more expensive to do, but it's been done so many times that, like, go look at all the people that have done it. I'm sure that you can go find a college lab, right, that has the equipment that will allow you to do some basic laser interferometry experiments. It's really not that difficult. All these things can be done. But on the other side, there's never a call for an experiment. There's never like, well, look at this observation. Look at it. There's never that. And then when I say, okay, they said this, well, how do I know? And now you're like, oh, well, I don't want to do all the I don't believe you thing. Hey, don't get me wrong. You a slick brother, you feel me? But I'm slick too. All right, I caught that. You feel me? I you know what I mean? You trying to run the game on me. You feel me? Trying to. I know you. Yeah, you trying to run a game on me. Anyways, man, I'm like I said, I'm not gonna press you too hard on that, but because I know the answer to that question already. Like I said, the answer is they don't have anything on the moon that they're receiving back. They say that they have. I can't think of the name of the quote unquote. I think it's something Debbie Center that they say that they're getting info from because it's floating around the sun. But then when you look at all the readings, they're not getting any readings from around the sun. All the readings that they're getting are coming straight from Earth or in high and upper or Earth atmosphere from their satelloons or from airplanes and stuff. Anyways, all right. So I'll start you out on the moon thing, man. Like I said, you know, and even then, even if what you said was true, that still is not proof that we went to the moon. I mean, even if we did put something up there, right? All that's proof that maybe we shot something up there, right? Hey, maybe we shot the thing up there, right? And right. So there's a lot of other options besides us having been there ourselves from something being on the moon that we can receive frequencies from. You know what I mean?
You're right.
And like I said, man, I do.
Any other questions I missed or didn't answer or something?
No. You good, brother. I honestly, I appreciate you, man. Anybody who's ever seen any of my content, I'm sure that they know that this is probably the comments that I've ever been, and that's 100% a result because you've been 100% respectful the whole time. You know what I mean? I've tried not to interrupt you. I don't think you've interrupted me one time. You know what I mean? And so that's what I'm saying. Like anytime you want to come on and challenge me about anything, you're more than welcome, man. Because I can tell that you're genuine. You know, you don't take what I say personally. And I can sense that, you know, you're at least willing, you know what I mean, to admit that you might be wrong. Even if you don't think you're wrong, you're at least willing to admit that, okay, fine, if I am wrong, I'm at least willing to accept that I might be, so I can see the other side. Whether you agree with me or not, I can sense that genuineness in you. So I appreciate you. Like I said, you're always invited on, my brother.
Thanks, brother. Thank you for the welcome, and I appreciate being here.
Hey, of course, man, and I look forward to hopefully chatting with you again, man. You know what I mean? Like I said, you know, like these are subjects that I know intimately. A lot of them, you know, I haven't like looked at in a while. Like the gravity thing is like it's something that I started researching right out of college, and so you know, sometimes I have to go back and brush up on a lot of the stuff that I read because I might have read it 1 or 2 times, and just the key pieces of the information are in there. You know what I mean? Like when you ask me specifically about, you know what I mean, the details of how they created the star is like I don't remember every single detail. I just remember that they did this, boom, boom, boom. And so I would have to go back and read up on it, you know, specifically to answer a lot of those questions. You know what
I mean? Okay, sounds good. Yeah, when you get the information, let me know. I could come back.
Yes, sir. Yes, sir. Yeah, we'll be in contact on Instagram. You feel me? So, you know what I mean? Once again, thanks for coming, bro. And, you know, enjoy the rest of your day, man.
Sounds good. Be cool.